Hi, everybody. It's Professor Mitchell. Today we're starting Chapter 2 on equations, inequalities, and problem solving. And we're going to start with Section 2.1 on simplifying algebraic expressions. In this section, we will identify terms, like terms, and unlike terms. We will combine like terms. And we will use the distributive property to remove parentheses. And wait a second, I think there's one more. Yes, we will write word phrases as algebraic expressions. At the beginning of each section, I like to talk about which of the student learning outcomes for the course is covered by this section. And in this case, it would be performing mathematical operations on algebraic expressions. And I'm not even going to read the rest of that because those examples will actually come up in later chapters. All right, so it's very common in a math class and maybe in other classes to start a new chapter with some vocabulary. All right, so when we talk about a term in algebra, we're talking about either a real number or the product of a real number and some variables raised to whole number powers. Remember that whole numbers are numbers like 0, 1, 2, 3, et cetera, et cetera. So the exponents cannot be negative numbers. They cannot be fractions. All right, those are valid expressions, but they are not terms. All right, so here are some examples of terms. We have the number 6, which is a real number. We have the variable x. We have 2a squared b, negative 7z squared, and 3/4 yz squared. 3/4 is also a real number. The numerical coefficient of a term is the numerical factor of the term. So in these examples, the numerical coefficients would be 6, 1. Remember that when you have a term like x, there is an invisible 1 there. You can think of that as 1x. 2, negative 7, and 3/4. Those are all the numerical coefficients. Usually we just call them coefficients. Like terms are terms that have the same variables raised to the same powers. All right, so here are some examples, and the question is, which of these pairs are like terms? 6x and negative 4x, are those like terms? Well, yes, they are, because the variable part in both is x, and it's x to the same power, which is the first power. X can be thought of as x to the first power. 1/2 y squared z and 3/4 y squared z. Are these like terms? Well, yes, they are. The coefficients are not what we call like fractions, but there we're using the word like in a different way. The important thing about this is that the variable part on both is y squared z. All right, how about 7ab squared and 2/10 b squared a? Are those like terms? And now I'm getting a little tricky. Well, those are also like terms. I've written the variable parts in a different order. One of them has ab squared, the other one has b squared a. But remember, the definition is same variables raised to the same powers. They both have a to the first power and they both have b to the second power. It doesn't matter what order those are written in. So how about 4c cubed d squared and 4c squared d cubed? Are those like terms? And the answer is no, they're not. In one term, c is to the third power, and in the other term, c is to the second power. So those are not like terms. All right, next we're going to talk about simplifying using the distributive property. So here are the examples. I'll remind you in just a second what the distributive property is. You'll see that in the examples. I am going to do these examples on my tablet. So let me switch over to that. If you're wondering what that squawking noise is in the background, those are my birds. All right. First example, 9 times z plus 7 minus 15. Directions were to simplify using the distributive property. The distributive property talks about multiplying like this. Okay, sometimes it's called the distributive property of multiplication over addition. And it says that you can multiply each term, in this case, by 9. So this would be 9 times z, which is 9z, plus 9 times 7, which is 63. And then the minus 15 is going to stay as a minus 15 because that is not part of the expression that's getting the 9 distributed onto it, right? The parentheses are closed off before the minus 15. So now we're going to combine our like terms, which are just these numerical terms. 63 minus 15 is 48. So the final answer is 9z plus 48. Remember that expression now is in simplest form. Don't say that that's 57z or anything else. Those are not like terms because one of them has a z and the other one does not. So they have to stay separate. Next example, negative y plus 5z minus 7. In other words, the opposite of the expression y plus 5z minus 7. You can think of this minus sign outside as a -1, which you might find helpful. So now I'm going to multiply every term by -1. And what I want you to notice in particular is what that does to the signs inside. So we have -1 times y plus -1 times 5z minus -1 times 7. And I hope what I'm doing with these signs is not confusing to you. I will not always write it this way. Okay. -1 times y can just be written as opposite y. -1 times 5z is opposite 5z. And then, of course, -1 times 7 is -7. All right, so now I'd like to pretty that up a little bit. Remember that adding -5z is the same thing as subtracting 5z. Subtraction is defined as adding the opposite. So usually if you're trying to simplify an expression and there's a choice between having parentheses or not having parentheses, we try to write it so that we don't need the parentheses if possible. So in this case, it would be opposite y minus 5z plus 7. Remember that subtracting -7 is the same thing as adding 7. All right, so now what I want to point out to you is that the signs in the original expression inside the parentheses were plus. When there's no sign, think of it as a plus, 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 minus. And after I distributed the -1, the signs go minus, minus, plus. So you might find it helpful to remember that anytime you distribute a negative number, it changes all the signs. Okay. All right, last example in this batch, we have 1/5 times 9y plus 2 plus 1/10 times 2y minus 1. All right, don't be afraid of the fractions. We're going to distribute the 1/5 onto those two terms, distribute 1/10 onto these two terms, and that's going to give me 1/5 times 9y plus 1/5 times 2 plus 1/10 times 2y minus 1/10 times 1. All right, now lots of people find it helpful to remember that when multiplying a fraction by a whole number, you can always sneak a 1 underneath the whole number part. Okay, and then you can just multiply straight across. So 1/5 times 9y over 1 would just be 9y over 5. 1/5 times 2 over 1 is just 2 over 5. Now I'm going to do something a little different with 1/10 times 2y over 1. 2y and 10 have a common factor, 2. So I'm going to take out that common factor as I go along. 10 divided by 2 is 5. 2 divided by 2 is 1. So instead of writing that product, that multiplication, as 2y over 10, I am going to write it as y over 5. And then finally, 1/10 times 1 is just 1/10. Any number times 1 is itself. All right, we're almost there. So now I'm going to combine the like terms. We have one pair of like terms here because they both have y in them. And we have another pair of like terms here because these are just numerical terms. Notice I'm including the minus. So why don't we write those like terms next to each other? We have 9y over 5 plus y over 5. And then next door, I'm going to write 2 over 5 minus 1 over 10. All right. So 9y over 5 plus y over 5 would just be 10y over 5. Okay, and now in order to do 2/5 minus 1/10, I need a common denominator, which would be 10. So let's multiply the top and the bottom of this fraction by 2. Oh, now the dog is bothering the cat. Never a dull moment in my house. All right. 2 over 2 times 2/5 is 4 over 10. Okay, so now you can see why I did that, right? Because now that both fractions are over 10, they're very easy to subtract. And not only that, but I have this 10y over 5 here. 10 divided by 5 is 2. So the final answer is 2y plus 3 over 10. All right, that was kind of a long problem. All right. Okay, back to the presentation. I believe, yes, I think this is the last thing we have to do in this section. We're going to translate, excuse me, each of the following into an algebraic expression, then simplify. And I've written all of these down on the tablet. So rather than read them now and then have to read them again, I'll just switch over to the tablet. If I can find that button that I just used. There it is. Okay, so subtract 4 plus 3y from 8 minus 5y. This is a favorite thing of mine, subtract from. And there are two things about it that you need to know. First of all, the phrase subtract from, all right? Forget about 4 plus 3y and 8 minus 5y. Suppose it said subtract 2 from 10. Does that mean 2 minus 10? Or does it mean 10 minus 2? It means 10 minus 2, right? So one thing you have to remember about subtract from is that it changes the order. So this is going to be something like 8 minus 5y minus 4 plus 3y. Okay, except not quite. There is one more thing that I need to point out about this. What is it that we're subtracting from 8 minus 5y? We are subtracting 4 plus 3y. which means whenever you subtract an expression that has more than one term, you have to put that expression in parentheses. If I don't put it in parentheses, then I'm not subtracting 4 plus 3y. I am subtracting 4 and then adding 3y, which is not what it says. Okay. So remember those two things: changes the order and put the second expression in parentheses. Okay. And once you've done that, you should be good to go. Remember that example we did earlier where we distributed the -1. I'm going to do that first. It's going to make this 8 minus 5y minus 4 minus 3y. And now I will combine my like terms. I have some numerical terms, 8 minus 4. And I also have some variable terms. I have negative 5y minus 3y. And that is going to give me 4. 8 minus 4 is 4. And negative 5y minus 3y is minus 8y. All right. Next, the difference of a number and 2 . All right, next example, the difference of a number and 2 divided by 5. So notice the comma there. That was kind of nice of them to put that in. Otherwise, it might be a little ambiguous with the order of operations. Remember that difference means subtract. So what we're doing here is we're taking the difference of a number, and usually we'll write a mystery number as x or some other letter. Sometimes they use n, minus 2. All right, and because we've got the comma separating that phrase from divided by 5, it means we're going to divide that difference by 5, the whole expression. So I would write that like this. And then finally, we have half a number minus the product of the number and 8. So let's start with half a number. You can write that as 1/2 x. You can also write it as 0.5x. They mean the same thing. Minus the product. Remember, product means multiplication. And usually instead of x times 8, we write 8x. Okay. Now, because those are like terms, we can simplify that. In order to simplify it, we're going to have to get a common denominator. So let's start by writing this 8 as 8 over 1. And then the common denominator would be 2. So I'm going to multiply the top and the bottom of this thing by 2. Oopsie, almost forgot my x here. All right, so now we have 1/2 x minus 16 over 2x. All right, so to combine those like terms, we will subtract the coefficients. 1/2 minus 16 over 2 is negative 15 over 2. And don't forget the x. And that is going to take care of section 2.1. We will see you next time.